All right, so so what we're gonna do is we're gonna start talking about when something go to infinite. What I mean by that is if you ever have limits as x approach infinity, so let's say limit x approach infinity of 3x squared plus 2x over 7x squared plus 3x plus 1. So without telling you how to do it, does anybody know what happened when limit x approach infinity? Jenny? It's a positive, okay. Galen?
It's decreasing. Like I know the denominator is going to get bigger than the numerator.
Okay, that's a good start.
I mean the slope decreases or the rate.
I don't know, I'm asking you. So, yes, McKenna?
Does it get close to 0, but it hasn't also at 0, so we'll never actually reach it?
Okay. Anybody else? Eli?
Does it approach like 3/7?
Okay. Anybody else? Horizontal asymptote? Okay. Anybody else? I'm just asking. I didn't teach you, so you're not supposed to know. But according to all your prior knowledge, what does it tell you? Anybody else?
I think I agree with McKenna.
Go to 0. McKenna says go to 0, right?
What is that fraction? That fraction.
Because it can't equal 0.
Okay, that's a Amen. Okay. Never reach 1. Anybody else? Fiona?
I agree with what Eli was saying, because isn't your, if your highest x, degree, x power appears the same, then don't you just get the coefficients of each and divide imaginary?
Okay. So we have a few answers around, right? So now what we're gonna do is we wanna ask you to compare. So let's just say if I compare those two terms, let's say infinity square and infinity, right? So let's just say if I don't want to do infinity, I'll just do not a very big number, but big enough to see the difference. So let's just say if we have 1,000 square, right, versus 1,000. So what's 1,000 square? 1 million, right? Because basically like this, right? Versus 1,000, right? So just even 1,000 square versus 1,000 is already big difference. We not increase to where the number is gonna be 10,000, 100,000, 1 trillion, right? If 1 trillion square, it's gonna be a lot of zeros. So what I'm trying to say is this term and this term and this one, it becomes sort of insignificant. Then you only compare like 3 infinity square and 7 infinity square. So, and roughly that's probably gonna get what Eli says 3/7. And there's something to do with horizontal asymptote. Yes. And I'm going to talk about both today. But let's talk about mathematically speaking. In pre-calc, it doesn't matter. Apparently, all these classes have talked about these things very, very focused on it. So at least Eli and Fiona. Fiona, you're from Ollie, right? From Kench? Okay. Now, so what you're gonna do is you compare the x squared and x squared. So, but mathematically, how do we approach it? You divide it by the highest degree of denominator. Highest degree of denominator. Okay. Then I'm gonna say limits as x approach infinity. I'm gonna rewrite all this question. So what is highest degree of denominator? X squared, right? So I'm gonna divide this by x squared, x squared, x squared, x squared, x squared. And if you do that, I can simplify it. So it'd be 3 plus 2 over x over 7 over 7 plus 3 over x plus 1 over x squared. Now, what's interesting thing is this is a calculus way to approach something. If I say limits x approach infinity on 2 over x, why did I choose 2 over 2? Because limit x approach infinity of 3 is equal to 3. That's not going to change. It's just horizontal line at y equal to 3. So reach infinity is still going to be 3. But limit x approach infinity on 2 over x, a lot of people don't understand that. Now, if you don't understand that, I'm going to give you an analogy where you can see it. So imagine 2 over 10 is 0.2. And I'm increasing the number to 100, so it'll be 0.02. Increase to 1,000. What's the number approaching? Approaching 0, right? As the bigger the number on the bottom, and the top is the constant, some number that doesn't change, this is going to go to 0. Gabby is on out again. You kind of stare into the wrong direction. Don't zone out. You have to be here. So the answer is going to be 3 over 7. Is that okay? Yes.
That was just after we divided by the denominator, it's just the first number.
Yeah, so you try to create, you divide it by highest degree of denominator. You try to create a situation that you can see limit x approaches 0. And if everything else, so this can simplify, all other terms gonna pretty much gonna go 0 if you have x on the bottom. Now, what happens if you have a really large number? Let's just say 900, 9,009, I don't know, over x, when limits x approach infinity. Does it matter?
No.
No, because 99999 is still a constant. Even though it's a very large number, when bottom approach infinity, infinity is still way greater than that big number is. It could be 9 trillion for all matter, if they are the same. So that's equal to 0. Still. Now let me ask you a question. What happens if you limit x approach negative infinity on 2 over x? Neither? What do you think? It's approaching 0. Why is it approaching 0? Because imagine 2 over negative 10, 2 over negative 100, 2 over negative 1,000. So it's still going to be 0.2, but it's negative now, negative 0.02, and negative 0.002, right? It's going to get smaller and smaller, but in different perspective. Does that make sense? Okay. So what happened if you limit x approach infinity on 3x plus 3 over 6x squared plus 2x minus 1? Sorry, let me pick a different thing. Let me pick a... Oh yeah, infinity is fine. What do you divide here? You divide by what? X squared. So I just pick x squared here. And pick x squared here, pick x squared here, pick x squared, and pick x squared. And this will be simplified to limit x approaching infinity of 3 over x plus 3 over x squared, which is the x is on the bottom, top is constant. You kind of know what the result is. Minus 1 over x squared. So this is going to go to 0, this is going to go to 0, this is going to go to 0, this is going to go to 0. And 0 over 6, which is 0. Which is, that means you got horizontal asymptote at 0. So this is also known as horizontal asymptote. We're gonna make a connection to horizontal asymptote in a second, but we never mentioned the horizontal asymptote. Right now, we just mentioned limit x approaching infinity. What?
How is it a horizontal?
Okay, let's just show you on a graph. So this you got, let's say, let's just say, what is it? 3x plus 3 divided by what? 6x.
Squared plus
Huh? Minus 1 on the bottom. Okay, so y equal to 0. Okay, so and you're gonna be like, wait, that's not horizontal asymptote because it touches, right? So what happened? There was a vertical asymptote here. I don't know what it is, but you have the neo-quadratic formula to find it. But just say I change this to maybe, let's say, maybe like 2x, so I can find out horizontal asymptote. Where's the horizontal asymptote at anyway? X equal to 0, right? If you factor out x, what else? If you factor out 2x, it's gonna be 3x plus 1, so negative 1/3. Is that right? I don't think it's negative 1/3. X equal to negative 1/3. Then there's a graph. There's a graph in between though. Oh yeah, there's a graph in between. Yeah. So there's a 2 asymptote, right? And you're gonna say, wait, vertical asymptote, they never reach that value. Never ever reach that value. So I give an analogy to, like, it's probably gonna offend somebody, but don't offend somebody if, hopefully nobody's offended. But just think about your orientation, like sexual orientation, right? Like vertical asymptote, the way I kind of an analogy is vertical asymptote is like you grew up, you know you are gay. Like there's nothing can change about you. You are just gay, for sure. They are never gonna touch that point. They're not gonna touch a vertical asymptote. Now, horizontal asymptote on another case is actually like you're not sure you're gay, but you experiment. You're like, okay. And some people, actually, this happen in life too. Some people get married, and later down they get divorced. They find out they're gay. Huh? I don't know if you understand what I'm trying to say. I hear it just means that they can cross the x, they can cross the horizontal asymptote. Because what happened? What happened with horizontal asymptote is when they reach infinity. What happened later in life? What happened in middle of life? It doesn't really matter. Between your 10-year-old to 30-year-old, it doesn't really matter. It happened. What happened at the very end? Huh? I don't know. I mean, I don't know if that analogy makes sense. I don't like some people probably think like I'm trying to make fun of the situation. No, I'm trying to give an analogy that kind of makes sense. That it can cross in somewhere in the middle range of the graph. Okay, last year my thumbnail for this video was, is this graph bisexual? But you can still see the thumbnail on the video. Actually, you know who made that video? Who made that thumbnail? It's Aspen's sister. Do you know that?
Yeah, I knew that.
Oh, you knew that already. Okay. But hopefully you understand what I'm trying to say is horizontal asymptote you can cross in the middle part of the region. But later part, rest of it later, is they still like, okay, they are still asymptote. They still not gonna touch that point. Huh? Yes, let me speak of a reason, because the definition of horizontal asymptote is So the definition of horizontal asymptote and hopefully I didn't offend anybody. I don't care if you're gay, really.
Might have offended Jesus though.
What?
Maybe Jesus.
Ready, you wanna find out?
Whoa, 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 whoa. Take it easy. It's okay. Limit x approach infinity of f of x is equal to L. So at here is gonna reach infinity or negative infinity, right? If you reach infinity or negative infinity, it's gonna reach this L. So the definition in calculus is actually x happened to later in life, not in between. In between, they don't care because they just happen like what happened to value plateau into something. It doesn't matter in the middle, it can go across. You might go across and no one cares. But just happened what happened infinity or negative infinity all the way to the end. So I like to make it fun of situation, not make fun of this, but just make fun of for people can make a memory of okay, why is it the x can cross there? So yes.
Can it only cross one time or can it cross
That's a great question. I don't know about that. I never have that question come up before. Can it cross them like twice?
What?
Actually, I don't know. That's a great question. Can you cross horizontal asymptote twice and come back to plateau at the end? According to that's a great question. So can you cross if I were to guess, and I don't know, if I were to guess, I think it's possible rather than not possible. But at the end, it's still gonna plateau into a number. Right? At the end, it's still gonna plateau into a number. I think it's possible, but I think that's a great question for you to discover. And that's one question. Like some people ask me, like they think I know everything. I don't. If you ask me something I don't know, I will go investigate this. So for me, like I'll probably plug in a different type of function into the Desmo and to see what happened. Right? I don't know honestly. I think reasonably thinking, I can imagine a graph hit twice and then go to horizontal asymptote. I think it's possible because it's only talk about infinity. It doesn't talk about at the middle region. So the middle region does have can be a lot of things can happen. It just may be the function that we don't know about. But yeah, that would be a great question. But if it's in cross 2, wait, you find out equation that cross 2 times? Okay, I was gonna say that's pretty cool if you can. So that's what the definition of horizontal asymptote is. There's one more case. If the bottom is larger, right? Its bottom is larger. So its top is larger. That's an infinity of x to the third plus 2x squared over 6x squared plus 3x minus 1. And if I ever divided by highest degree of denominator, what is the highest degree of denominator? X squared, right? So if I go to x squared, x squared, x squared, and x squared, now you're gonna see that's limit x approaching infinity of this is x plus 2 over 6 plus 3 over x minus 1 over x squared. We know this is gonna go to what? 0. But on the top, it's gonna go infinite. So it'll be infinite plus 2 over 6. The 2 doesn't even matter anymore. 6 doesn't even matter anymore. That's just going to be infinity. In this particular case, there was no horizontal asymptote. Because the value is going to go to infinite. If it goes infinite, that means it's going to keep on increasing. But the definition of horizontal asymptote is the limit x approaching infinity is going to plateau into something. But in this case, does not plateau into any value. Okay. What'd you say? Shh. Fiona trying to ask me something. I cannot hear you if you guys are talking over her. Yes.
Once you goes like it's like a line that's you can't pass it.
Slant asymptote?
Yeah.
Oblique?
Oblique, is that the same thing?
No. Oblique is. Oh, this one you can have oblique. You're right. This one is numerator is larger by 1 degree. Yes, you can have oblique asymptote that's linear. It's like a probably at this case is probably 1/6 of x. But yeah, you can have oblique asymptote here. Yes, we're gonna talk about that later. Not right now. Right now, we just talk about horizontal. Now, from what I know, is what?
Mission.
My phone is ringing. Oh, okay, can somebody answer that? Can you answer that?
Like oh, so that we should, they're saying that Misha.
Misha, are you going home? Is this okay? Okay, so what I'm trying to say is, a lot of people. The reason why I make like that analogy is because a lot of people don't misunderstand horizontal asymptote. I think vertical asymptote just like, this plateau, they just cannot touch them. You just cannot touch them. They're just not touchable. But horizontal asymptote, it can touch. And obviously, I think Nelly just find a function that it can actually touch more than one time. It's actually infinite amount of time. It will actually plateau into a value. So basically, it's some type of sine wave, and it's gonna be oscillate and toward a plateau at the end. So yes, you can. That's why I say I think I never know about it until you guys mentioned it, until Kaden mentioned it, until Nelly was talking about it. So that you can. So, but just at the end, it's still gonna be plateau into a value. Yeah. Does that make sense? Okay. So this case, there's no horizontal asymptote, but you can have oblique asymptote because oblique asymptote is a line, right? So graph is gonna go up like this. So the graph is gonna go to infinite because it follow that slant asymptote. It's go to infinite. So you don't have horizontal asymptote. Now, what I know is horizontal asymptote and horizontal asymptote and slant asymptote cannot coexist because once you go to infinite, then you cannot have another horizontal asymptote. That doesn't make sense. So that I know for sure. So what Kaden asked is I'm not sure about that one, but Nelly just come up with a graph that does do that situation. So that obviously, so that's why I say I don't know, but you guys have find out discover the solutions. One of the things that you need to pay attention to is this function. So we talk about when limit x approach infinity and negative infinity. Why that matter? Why does that matter? Because sometimes you get this function like this. Like this. And you say, hey, can you find horizontal asymptote? Find horizontal asymptote. And then you say, okay, well, let me just limit x approach infinity on this case. And let me just limit x approach negative infinity on this case. And let's see what happened. But now, what's the highest degree on denominator? Huh? X. Okay, so let's divide this by x. Is that okay? But the problem is on the top, there's a radical. So what do I divide it by inside the radical? Why do you think it's x squared? X squared is absolutely right. Yeah, because the square root x squared is still x, right? But wait, let's hold it back. Square root x squared as of right now is equal to x. but later down it might change. So x squared. Is that okay? So why did I divide bottom by x, top by x squared? Because top is inside the square root. So square root of x squared is still x, right? So limit x approach infinity, that's equal to 9 plus 5 over x squared over 5 plus 2 over x. And when limits x approach infinity, in this case, this is going to go to 0, this is going to go to 0, so it'll be 3 over 5. Is that okay? Now let's talk about what the heck is square root x squared graph look like. So I'm going to look into it. So a lot of time that we're going to talk about what square root x graph look like. Right, that looks like this. And x squared graph looks like this. And let's put this in combination. If I combine this two, right, if I combine this two, then it's going to be square root of x squared. It's going to look like this. It's not just x. It's actually going to positive is x. Going negative is negative x. It's absolute value because it's always going to be positive because square root of something is always positive. So don't it become absolute value x squared? So this is a kind of hard to see, but imagine you do -2 square first, so it'll be 4, and square root of 4 is 2. So even though I plug in -2 squared is going to be positive. So that's why you got absolute value. So this one's actually equal to absolute value x, which is it has two definitions. This side is going to be x, and this side is going to be negative x. Is that okay? Now what happened is we're going to use this idea applied to the second one. The second one, I'm going to divide it by x. Now since I'm reaching negative infinity, when I divide it by here, I'm going to divide it this. Square root of negative x squared. Which is going to be negative x. But here, you're going to end up getting square root of 9x squared over x squared plus 5 over x squared all over 5x over x plus 2 over x. When limits as x approach infinity, that's equal to limits x approach infinity here. 9, but there's a minus sign here, sorry. 9 plus 5 over x squared over 5 plus 2 over x, and there's a negative sign. So end up to be -3 over 5. So you can have two horizontal asymptote, one on each side. It going like this. Now some people says, Mr. Ye, this is so hard to understand. Can I just memorize this 3 over 5 for square root, and the other side is going to be -3 over 4, or -3 over 5? In this case, it does work, but I'd rather teach you understanding because it's supposed to divide it by negative square root x squared. Now I'm going to look at this graph. Do you guys remember what the function is? What was the function? 9x squared. What is it? Plus 5? Over what? 5x plus 2. Right, it's looked like this. It looks good. You got, how do I find a vertical asymptote again? Bottom equals 0, so it'll be -2 over 5, right? So this is the asymptote. Okay, horizontal asymptote is going to be 3 over 5. So y equal to 3 over 5. Again, they cross again, right? And they only cross one time, so it's no big deal. Y equal to -3 over 5.
Yeah, it's 3 over -3 over 5.
-3 over 5, yeah. So do you see that on the infinity, horizontal asymptote only care about what happened at the end. They don't care about if in what happened in the middle part of your life. Yes.
I didn't get when you said it equal to the limit to negative infinity, why there was a negative on top.
Because remember when you go to negative infinity, you're gonna treat it as a negative root x squared. It's gonna be negative x. It's because absolute value x, right, is two functions, negative x from x is greater than less than 0, and positive x, x greater than 0. So we're looking at the negative x part. So it'll be negative x squared. So this is a negative sign here, and it causes this to be negative. Because I'm approaching negative infinity. I'm not approaching positive infinity. So I'm using negative side version of x, which is negative x.
But then when we say, but it's not really back where we put negative infinity.
It doesn't. It does. Yeah, negative infinity is going to be the same, but if I approach negative infinity, I'm going to use a negative power function. So I will show you another function that might deal with this. Yes, Nizar?
Actually, why do you divide it by the square root of x squared? Like negative x squared. Why did you not just divide by negative x squared?
Only the final sign it counts. I'll show you here. Maybe this will explain this problem. So this is f of x, and let's just say if I want to find out horizontal asymptote here, right? So I'm gonna treat it as limits x approach infinity of x over 2x minus 1. But if I approach negative infinity, I'm just gonna write like this: negative x over 2x minus 1, because I'm approaching the left side. 2x is positive. 2x is always positive. Only the top part can be negative or positive.
Oh, so
Huh?
Is the second limit supposed to be negative infinity? Or
No, I'm approaching infinity, so it's on the left side. So I place a negative x rather than positive x. So it's essentially I'm
they're both
approaching.
going to positive infinity?
Yeah, essentially this is the same as saying x approaching negative infinity of the function. So I here it's going to give you 1 over 2, and I here it's going to be give you negative 1, 2. So this represents same thing as x limit x approach to negative infinity of absolute value x of 2x minus 1, because I'm using negative side of functions. Nothing else matter, only the negative part it matter. So it's gonna, if you have a hard time understand this, that just knowing is positive and negative for the square root one. Tomorrow we're gonna talk about different cases with e to the x, which is we already did. E to the x has, we talked about on the first test, e to the infinity is what? Infinity? But e to the 0 is what? No, e to the 0, 1, and e to the negative infinity is 0. So tomorrow we're gonna finish that case on that situation. For the next few days, what we're gonna do is this. We are gonna do this. We're gonna finish this out tomorrow, and we're gonna start talking about harder graph, like talk about oblique asymptote, and talk about slant asymptote. Matter of fact, you might see an asymptote look like a parabola before. If you guys don't know, it's actually called second degree asymptote. You can have asymptote like a second degree instead of a straight line. You can have a lot of things situation happen, but none of the things that really gonna be in the calculus. But I'm still gonna talk about it because in UCF calculus, they actually talk about graphing those complicated functions. And I will assume same as any other college as well. So I want to make sure when you go to college that you still gonna be fine. And yeah, but this is today's lesson. Talk about infinity.